Hello, this is the video for our final project from the subject Advanced Programming. We're going to present our project that is about a simulation of traffic with threads. It is made on Golang. Here you see the structure of our project. This is the main folder. In this folder we have the architecture document, the city traffic document. Here we have a picture that is the background of the project. And here in the folder of scripts we have all the entities needed for the project. We have a game which has semaphores, and then we have semaphores which have cars. And the hot entity is needed for us to display information on the screen. And here we have all the images we needed to display at the project. And now I'm going to run the program so you can see our project.
Okay, so now for the first test, we need to go to the terminal and be at the city traffic folder where the main.go file is. At first, we need to put go, run, then the number of the main file, and 5 as an argument. 5 is the max number of cars that can be at each lane.
So now it's running. It's going to try and create 5 cars at each lane. Now currently the first lane has stopped, so now goes to the second lane, which is the south lane. The third lane will spawn 5 cars, well, a little bit more, 6 when it goes green. You see? And then a 6th car, because it has no more cars in it. The simulation tries to not overload the system with cars. It tries to get a maximum of cars. In this case of this instantiation, it's 5 cars. So it will not try and spawn a 6th car until it's free. And it continuously is checking.
Okay, now for the second test of our simulator, we are going to put a maximum of 4 cars in each lane. So we can see that faster cars go further than slower cars, and if a slower car is in front of a faster car, the faster car is going to be a little bit slower so they do not crash and it do not surpass the car in front of them.
So now we are going to wait for the cars to get in the queue. As you can see, current cars, will never go over 20 cars, given that we only have 4 cars per lane. As you can see, now that when they go faster, there you go. The faster car does not go over the slower car. When a car is turning, it sometimes overtakes the car, but because it goes technically to another lane. So that is why sometimes in the on the intersection, the car may go close to another car, like so. Some examples of concurrency in our project, starting by the car function. Well, not script, sorry. Our car script has 2 concurrent functions that we run when we initialize a car, which is check semaphore and match speed. Check semaphore checks, as the name implies, the state of the light of the lane that it's currently on. For example, if it's in lane 0, it checks the line that corresponds to check 0. And then we have the function match speed. It's over here somewhere. There you go. It runs every 10 milliseconds. We could have run it a little bit slower time, but we have some problems to arise with speed. So basically, it checks what queue it is going to be at, if it's going to be behind the light or if it's going to be in an exit queue. Then it gets the queue position over here at the top, and it checks the speed of the car that's in front of it in the queue, and it compares it to the speed of the car itself. It's important to note that we check the speed with a difference of approximately 250, because if we add it with a lower distance, we got into a lot of problems with it not refreshing on time, or it not checking the speed on time, and cars going over themselves.
Well, the queue manager, as my partner explained, is the one who manages the creation queues in each lane. For example, every semaphore will be running its own queue manager that will be sleeping during 3 seconds, and then it will try to check if the cars that it has spawned, the cars that are currently waiting at the light, is less than the maximum cars it can spawn, then it will spawn a car. It does this by using the build car command, which is a below function. This will create a build queue into the semaphores queue list, and a new car that is being constructed by this method, which is passed the game as a, how do you say, as a pointer, the position of the semaphore is at, and some other parameter it needs to function properly. That will be explained further in car.go.